we'll title this Graphing Sinusoidals, and what we're going to be looking at is both sine and cosine act the same way. And what we're going to give this an acronym. It's going to be the shortcut for graphing. I mean, you could use your transformations graphing and work from left to right and start with your stretches and compressions, then your translations. But we're going to find out if we know the properties of each of these attributes, the A, the B, the C, and the D, and how they affect sine and cosine graphs in particular, then we can create a shortcut for graphing these quicker. And this shortcut I call DAB C. Now, what does DAB C stand for? Well, the DAB C stands for do the D value first. What does the D value represent when you're thinking about sine and cosine graphs? That represents your center line, your sinusoidal axes. So we're going to start with graphing our sinusoidal axes first. Next is our A value. Our A value in our sine and cosine graphs stood for our amplitude. So we are going to use the amplitude to label the max and minimum y values. Because you can use your center line and go up from your center line with your amplitude and down from your center line with your amplitude. You're going to use the B value to find the period. Remember, our period is 2 pi over our B value. And we've done this before, like when we graph our normal sine and cosine graph. You label your period, which is 2 pi, and then you broke it up into 4 equal sections, which was your axis family. And when we saw in the last section, when the B value changed, we did the same thing. We labeled our new period and then divided it into 4 equal sections. So this is what we're going to do to start. And then the dash actually means something in the DAB C. So we're going to add the dashes here and write put that in between 2 dashes. You're then going to apply the fact that you know where the center line is, what the max and the min, and that your period is divided into 4 sections. You're going to graph it temporarily. If you have a sine graph, you'll start in the middle going up. If you have a coast graph, you'll start at a maximum. And you'll draw it with a dotted line because the very last thing you need to do is graph it with your phase shift. And if you have the actual graph with the dotted line first, just taking that graph and moving it to the left or right will be fairly easy. So now that's the technique in words for the DAB C. And the DAB C is just an acronym to remember the order in which you're going to do your graphing. You're going to start with the DAB, temporarily graph it, and then add the C afterwards. So what does this look like? Well, at the bottom of the page, let's add a graph. Let's do 3 cos 2 x minus pi over 4 plus 1. So we want to graph this. Okay. What are we going to start with? According to, all right, DAB C over here, we're going to start with drawing our center line. Our center line, the D value is plus 1. So at 1, I'll draw my center line at y equals 1. D value, check. Next, A value. Use your amplitude to figure out what your maximum and minimum will be. My amplitude is 3. So I go for my center line, I will go up 3. My maximum will be 4. I go for my center line, I go down 3. My minimum will be negative 2. A value. Check. B. Use your B value to find your period. So off to the side here, I know that my period is equal to 2 pi divided by my B value, which is 2. That means that my period is pi. So I go on my x-axis, I mark pi, and I divide it into 4 equal sections. So this will be pi over 2, pi over 4, 1 pi over 4, 2 pi over 4. This will be 3 pi over 4. B value. We are now done the DAB part. We next get to the dash, and the dash means temporarily graph it without your phase shift. So what are we graphing? We're graphing a coast graph. Where does a coast graph start? Coast graph starts at a maximum, then goes to your center line, then to your minimum, back to your center line, back to your maximum. Draw that. With a dotted line. Finally, so check it off, we now have done the dash part. Yes? So the amplitude is 3 from your A value, and that's the distance from your center line to the maximum. So that's how I found out that 4 was going to be my highest point. Just added and subtracted 3 from my center line. And finally, our phase shift is pi over 4 to the right. So we take our temporarily drawn graph, and we take each point, and I'll draw my final. So I take this point here, and I need to shift it pi over 4 to the right. And I take this point here, and I shift it pi over 4 to the right. This point here, shift it pi over 4 to the right. This point here, shift it pi over 4 to the right. And finally, this point there, shift it pi over 4 to the right. And I can now draw my final graph through those points My final graph is a solid line. So that means everything that's dotted in this graph is just to help us see what it looks like. But our final graph is what it is.